Okay, hi, welcome to Math 12A again. Don't forget that your assignments are due March 31st, I believe. Just a sec, don't spin the other way. They are due March 31st, so be working on those. I've given you several days to work on those exclusively, so you should be doing okay with that. I've tried to answer any questions that have come in about it. The last homework that you did was out of section 7.2. I really didn't get any questions from anybody, so I'm assuming it all went well. That's my assumption. If it didn't, you need to tell me. We're going to move into section 7.3. Sorry, I have a dog hair on my lip, which talks about angles in a circle. Now, before we do any examples with that, we need to talk about a few terms first. They're easy, they're quick, no worries. I still have that dog hair on my lip. And then we're not going to be proving anything, we're not going to be doing anything, we're actually going to be working with numbers, looking for numbers. It's going to be numbers based, not you writing out theorems or anything. I have a dog spinning in front of me just there he goes. Okay, so when we have a circle, okay, when we have a circle, not bad. All right, when we have a circle, if we have an angle inside a circle, so we have a chord here and a chord here, all right? So we'll say this chord ends here and the other one ends here, and they both start at the same place. An angle that happens at the edge of a circle, like this, is called an inscribed angle. So an inscribed angle is just an angle that happens at the edge of a circle. All right? Now, where these two chords come out and touch the circle, the part of the circle, the curved edge of the circle, and I'm doing this in another color so that hopefully you can see it, the part that joins, the short part of the circle, okay, that joins this is called the minor arc. Arc because it's a curved line, minor because you could look at it as the part of the circle that joins these 2 points is around the long way, okay? The long way, around the long way like that, is called the major arc, okay? Now, they use geometry language when they talk about this, and so if this was labeled, say, A, B, C, okay, I would say that these 2 points are inscribed, sorry, is that the word? That they are, sorry, I'm just checking something. Yeah, that they are inscribed, that angle A is inscribed by BC, all right? It's inscribed by the arc BC. Now, if the center of the circle was here, and say I drew a radius from the center of the circle out to this same point, and I drew another radius from the center of this circle out to this point, okay? The angle that's here, this is called, and this should not be like a shocker, this is called a central angle. And that's because it happens at the center of a circle. Not rocket science, central angle, center of the circle. And so let's call this point D. And so I could say that angle A and angle D are inscribed, I didn't finish that word, are inscribed by exactly the same arc. In other words, angle A comes out to these 2 points, so it's joined by this arc, and angle D comes out to these 2 points. So it's also inscribed by that arc. So angle A and angle D are inscribed by the same arc. That's the language that they will use. Now, there are some theorems when it comes to this. And again, I'm never going to ask you to write out the theorems, but you do need to know them in order to apply them. And you'll see what I mean when we do a couple of examples. So, the theorems are on page 411. That's where they are. And the first one says a central angle is 2 times bigger than an inscribed angle that are, here's the word that I wanted, that are subtended. Subtended is the word. Oh, here we go, subtended. That are subtended by the same arc. That just means joined by the same arc. So we have the inscribed angle, we have the central angle. So whatever this one is, it's 2 times bigger than what this one is. So if I knew that this one was 80, then I would know that this one is 40. If I knew that this one was 40, then I would know that this one is 80. The central angle is always 2 times bigger than the inscribed angle that are subtended, that are joined by the same arc. All right, they have to come out, the inscribed angle and the central angle have to come out to exactly the same 2 points for that to be true. Now, inscribed angles subtended, which just means joined by the same arc, are always equal. And I will show you what that looks like. So, I hate to erase this circle, it was so good. All right. So, I'll never make another circle that good again, just hold on. Yeah, see, that one's not as good. All right, but if I had an inscribed angle, an angle on the edge, and let's say it came out to this point and this point, all right? So it is subtended by that arc right there. And let's say I had another inscribed angle, another angle that's at the edge of the circle. Say it was over here. And it came out to here and to here. So it is also subtended, it is also joined by exactly the same arc. That means that this angle and this angle have to be the same. Whatever they are, they have to be the same. All right, and then they make one that's sort of obvious. They make one that's kind of obvious. They say the angle inscribed in a semicircle is a right angle. So a semicircle, here's the center. A semicircle is just half a circle, all right? And so what they're saying is if you have an inscribed angle, this angle has to be 90 degrees. But if you know this one, you know that, because this is a central angle, and since it's a straight line, it's 180 degrees. And we know that a central angle is 2 times bigger than the inscribed angle, so it only makes sense. All right, so here is where this being online is kind of a pain, because what I would do if we were in a classroom is I would do the next couple of examples with you, but I would be getting you guys to figure this out and not me. Unfortunately, I can't do that. So, in example number 4 on page 411, so that's where I am. I'm at example number 4 on page 411. We have a circle, okay? And we have something that comes out to here, we have another something that comes out to here, and there is a line that goes here, and they tell us that this angle right here is 105 degrees. And they label this A, B, C, D, and E. Now that should touch the edge of the circle. It's just me. All right. And they also tell us that this angle is 70 degrees. And they put little unknowns in red. They put a little 1 here, and they put a little 2 here. And what that means is they want you to figure out, and I don't care whether you put 1 and 2, maybe you don't like having more numbers there, maybe it's confusing. We can call this X and we can call this Y if you want to. I don't care what you call it. That's what they want you to figure out. So, how you go about this may be different than how someone else goes about it. As long as your logic is sound, it's fine. How will I know if your logic is sound? That's hard because I don't make you write out like what your thoughts were exactly. But if you had to do some math, if you had to add a couple of numbers together, if you had to subtract some numbers together, if you had to divide or multiply or something, just write out that you did that. But you don't have to write like inscribed angles, subtended. You don't have to write out all that. So I would actually figure out what I'm calling Y. I would actually figure that out first. And there wouldn't be any math to show because angle A, and I'm going to do this in a different color, angle A comes out to point B and point C. Angle D also comes out, if I follow the lines, also comes out to point B and point C, which means both of those angles are subtended by the same arc. So that would mean that Y has to be the same as this. So that means Y is 70 degrees. For those of you who hate showing work, congratulations. Here's a section where you don't really have to very much. If you put 70 degrees, I'm going to know that your thinking was this and this are equal. I'll know that. Now, we have to figure out X. That one might take a little bit more thinking than the other ones. I don't know. And really, it's up to you how you go about figuring this out. There can be a lot of different ways to do that. I'm looking at how they did it in the textbook just to see. They did this one. Think way, 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 way back. We talked in probably in the lesson on chapter 6. We talked about if you have a triangle and one of the lines extends, if you know this exterior angle, it is equal to the interior opposite angles added together. So this angle is whatever this one plus this one is. That is called the exterior angle theorem. See why I said you need to know these? It's not that you need to write them out, but you need to know them in order to be able to find the numbers. So if I use that logic, if I look here at this blue triangle that I'm doing, if I look at this blue triangle, there's the exterior angle. It is equal to the addition of the two opposite angles. And I already know this one is 70 degrees. So 105 would equal 70 plus that x. And so if I bring this 70 over here, 105 minus 70 would be x, and x would be 35 degrees. So x is 35 degrees. So what work would I expect to see? Something like that. I would expect to see that you did 105 minus 70 so that I know kind of where your thinking was. Example number 5, and it's the last one I'm doing. This takes a lot longer in class because I make you guys figure it out. So this is actually going a lot faster than it would in class. All right, I hate drawing this one. So we have this circle, and we have A to B. We have B to C. We have the center of the circle is about here. We have A to C, but A to C is not going through the center of the circle. That's important to note. But then we have a line here. They label the center of the circle O. They always label the center of the circle O. And then they have a point D out here, and that is going through the center of the circle, and then they join here. So that's basically the picture that's in your textbook. So again, let's figure out what they label. They give us one angle, and one angle only. They tell us this is 56 degrees. And they say they want us to figure out BAC. So they want to figure out this. I'm going to label it X because I like having a visual so that I can see what it is I'm figuring out. They also want us to figure out CBD. So they want us to figure out this. We'll call it Y. And finally, they want us to figure out BOC. So they want us to figure out this one. We'll call it Z. Now, just because I label it X, Y, and Z, that does not mean that you have to figure it out in that order. If there's something that you see right away, then put that one down. I don't care the order that you figure it out. So I'm looking at this. I see Y first, actually. And the reason why I see Y first is if I look at Y, it comes out to point C and point D. This 56 comes out to point C and point D. This angle and this angle are subtended by the same arc. They both are subtended, joined by C to D. And so that means that Y is 56 degrees. Now that's the one I saw first. It might not be the one you see first, but it just happens to be the one that I saw first. Then what can I see now? Well, oh, I see one. I can figure out X, and here's how. Remember I said that a central angle is 2 times bigger than the inscribed angle. Well, if we look here, not just at the Z, but at this whole thing, the whole piece right there, that's 180 degrees because this line is a diameter. It's going right through the center. So it starts at B and ends at D. If I look up here, this whole angle right here goes out to B and out to D. So if this is 180, it is 2 times bigger than whatever this whole thing is, which means 56 plus whatever X is has to be half of 180 because the central angle is always 2 times bigger than the inscribed angle. So that would be 90 degrees. And so X would be 90 minus 56. And so X would be 34 degrees. If I did the math in my head right, good for me. X would be 34 degrees. So I only have one more that I have to figure out. I have to figure out, and I'm just going to take that away. I just have to figure out this little one right in there. So again, that's a central angle. Is it inscribed? Is there an inscribed angle that would come out to the same thing? So this comes out to B and C. Well, this X that I just figured out, it comes out to B and C as well. So this is a central angle. This is an inscribed angle. The central angle is always 2 times bigger. So Z has to be 2 times whatever my X is. This one comes out to B and C. This one also comes out to B and C, but this is a central angle. This is an inscribed angle. So the Z has to be 2 times bigger than my X. And I know that my X is 34 degrees because I already figured that out. And so that is 68 degrees. And I've just figured all the things they wanted out. So you're going to try a few of them. If there are some that you can't get, I encourage you guys to kind of talk back and forth with each other. I know you can't do it face to face, or you shouldn't be doing it face to face unless you're doing it through a computer screen. But I do encourage you to kind of talk it out if you need to. If you really need me to go over some, I'm more than willing to do that. I'll do another video going through them again. But the more you can do it on your own, the more you can think through it, the better it's going to be. Because I can't say it's always going to work this way. You just have to know the theorems. You have to know the rules so that you can apply them in different scenarios, okay? So in classroom, there'll be a list of questions I want you to do. So you have until at least Monday to do that. You have until Monday. You have until Monday to do that. And don't forget your assignment is due on the 31st. Talk to you soon.